Hello everyone. In this video, we will be solving a basic trig equation. Our problem here is to find all theta between 0 and 2 pi, satisfying sine squared of theta equals sine of negative theta. In general, our strategy for solving trig equations is to move everything to one side so that 0 is on the other side. Once we do this, we want to use known identities such as the Pythagorean theorem to simplify our expression. After we simplify using IDs, we want to try and break the expression into factors, or if we happen to notice that we have a quadratic equation, we can use the quadratic formula. So let's solve our problem. For our equation, we have sine squared of theta on one side and sine of negative theta on the other. We want to move sine of negative theta to the side with sine squared of theta. To do this, we will subtract sine of negative theta on both sides, after which we get sine squared of theta minus sine of negative theta, and this will be equal to 0. Now, we want to use identities or known properties to simplify this equation. We see here that sine has a negative argument here. We want to try and get rid of that in order to reduce the complexity of this equation. So one thing we can do here is remember that sine is an odd function. What this means is that we can actually take the negative that's on the input and apply it to the output. So pulling out that negative from the input, we get sine squared of theta, and then that negative combines with the negative that's already there, and we get plus sine of theta. And this is still equal to 0. Now we've moved everything to one side and gotten 0 on the other. What we now want to do is try and factor this. So recall that sine squared of theta means sine theta times sine theta. So both of these terms here, the first term and the second term, have sine of theta in them. This means that we can factor out sine of theta. And after doing that, we get sine theta times sine theta plus 1. And this is still equal to 0. If you distribute the sine theta, you'll see that this is true. Now we have two factors equal to 0. We have to recall that anytime we have two or more factors being multiplied and they are equal to 0, that means that any one of the factors could be 0. So this means that sine theta could be 0. It also means that sine theta plus 1 could be 0. So we need to examine each of these cases independently. So our first case is sine of theta equals 0. To figure out what theta satisfies this particular factor, we want to think back to the unit circle. So if we have our unit circle, we will remember that sine of theta happens to be the y-coordinate on the unit circle. So we want sine of theta to be 0. This means that the y-coordinate must be 0. The y-coordinate being 0 happens to be here on the x-axis. We must ask what angle then puts us on the x-axis. There's two locations where that happens. The first is here, and the second is here. What angles are these? Well, this particular angle is 0, and over here we have a pi radian rotation. So sine of theta equals 0. This implies that theta is equal to 0 or theta is equal to pi. We must now look at the second factor that we have. So our second factor is sine of theta plus 1. Sine of theta plus 1 could be 0 too. Solving for this, we have sine of theta equals negative 1. What angles will give us sine of theta equals negative 1? Well, to figure that out, we must go back to the unit circle. Sine of theta is the y-coordinate. We want y equals negative 1. This is going to be down here, y equals negative 1. So now we have to figure out what angle will put us here. Well, we know that a half rotation is pi radians. Pi radians puts us up here. From there, we want to go another half rotation down. So what we want is pi radians, our starting point, plus a half pi rotation from that location. And that will bring us down here. Simplifying this, we find that pi plus pi over 2 is 3 pi over 2. And this is, of course, the same thing as 1.5 pi rotations. So sine of theta equals -1 implies that theta is equal to 3 pi over 2. Now, there are no more solutions for the particular interval that we're looking at. There's only one place on the unit circle where y is equal to -1. To get any other locations where it's -1, we would have to travel around the unit circle more than once. However, if we look at the original problem here, it requires that theta be between 0 and 2 pi. So what this means is that there are no more solutions here. So after all this work, we find that the solution to our original trig equation, sine squared theta equals sine of negative theta, is theta equals 0, pi, or 3 pi over 2. And these are our solutions.